All right, today we're jumping into an incredible story. It's a mix of a high-stakes hackathon, a pretty radical cryptocurrency, and the future of quantum computing, all crashing together. This is the story of Qubitcoin, and how it's basically trying to hack its way into the quantum future.
So let's just start with a big question. Imagine you've created something revolutionary, something that could totally change the game in your field. It's complicated, it's new, and the stakes are super high. How do you actually know if it's going to work before you bet the farm on it?
Well, you don't just keep it in a sterile lab. You throw it out into the wild. You disguise it as a really, really hard puzzle, and you let the smartest, most creative people you can find just go to town on it. You let them try to break it. Or, even better, you see if they prove it's as strong as you hope it is.
And that's exactly what happened. Which brings us to our first section, a high-stakes quantum puzzle. But as you're about to see, this was way more than just some coding competition.
The scene is set in January 2026 at MIT's iQuHACK competition. I mean, you can just picture it, right? The place is absolutely buzzing with energy. Teams of brilliant students, researchers, all competing to solve some of the toughest problems in quantum computing. And then, a new challenge pops up on the board. A particularly nasty one called the Super Quantum Challenge.
Now, to get what this challenge is all about, you just need to know one thing, the T-count. The easiest way to think about it is like a golf score for a quantum program. The T-count measures a very specific and very expensive type of operation. And just like in golf, the lower your T-count, the better. A lower score means your circuit is way more efficient, way more powerful. So for every team, the goal was dead simple. Get that score as low as you possibly can. But what happened as the teams dug in was kind of weird, and it revealed what we're calling the winner's secret weapon.
So as the clock is ticking and the pressure is on, something really strange starts to happen. You have all these different teams working completely separately, and yet they start coming up with solutions that look almost identical. It turns out they had all stumbled upon the exact same powerful tool to crack the puzzle. This was definitely not a coincidence.
So what was this secret weapon? It was a tool called rmsynth. See, instead of just trying to brute force a solution, rmsynth takes this really elegant, almost mathematical approach to the problem. And as a post-competition analysis found out, it wasn't a fluke. The tool was practical, it was competitive, and it just worked. For multiple teams, again and again.
And this is where the story completely pivots. You see, this hackathon wasn't just a game. It was secretly a grand challenge with some absolutely massive real-world consequences.
Which kind of begs the question, right? Why all the fuss over this one specific puzzle? I mean, why was getting these T-counts down in this particular way so incredibly important that it became the star of a huge MIT competition?
And here's the twist. The Super Quantum Challenge was never just an academic exercise. It was a live, public stress test for the main engine behind Qubitcoin's next huge update, the Planck update. The competitors had absolutely no idea, but they were essentially beta testing the entire security model for the future of a cryptocurrency.
Now, to really get how big of a leap this is, you have to look at where Qubitcoin was coming from. Their old system, Cash, was all about simulating these noisy, kind of temporary quantum circuits. Think of it like early-stage R&D. But the new system, which they call David, is so much more ambitious. It's about building stable, properly era-corrected circuits that actually create lasting scientific value. It's a huge shift from just messing around to actually engineering something real.
So with all that in mind, who was the real winner of the hackathon? Well, it wasn't just one of the student teams. It was the Qubitcoin project itself. And the proof is in the numbers.
Let's look at a super concrete example from the challenge. The teams were handed this specific 4-qubit circuit. Now, a standard, pretty good way of compiling it would give you a T-count of 11, okay? So 11 is our baseline.
But then, check this out. Team Kuhn, using rmsynth, took that exact same circuit and crushed it down to just 4 T-gates. That is a 60% reduction. In quantum computing, where every single gate costs you time, money, and adds a risk of errors, that is a jaw-dropping improvement.
And it wasn't a one-off. Look at this. Multiple top teams, all coming at it from slightly different angles, ended up proving the same core idea.
Lil Luna was great at spotting algebraic shortcuts. The Q factor really drove home the connection to error correction. They all confirmed it from different directions. This approach isn't just a trick, it's robust.
So here's the bottom line. This whole hackathon became this amazing, unbiased, external proof that Qubitcoin's entire roadmap for the future was on the right track. It proved, out in the real world, that the technology they were betting on wasn't just possible, it was flat out better.
And this brings us to the final and maybe the most mind-bending idea of all. This is about changing what blockchain security even is, turning the act of reaching consensus into a motor for scientific progress. See, the hackathon results pointed to 4 massive wins for Qubitcoin. 1, lower T counts make mining cheaper so more people can participate. 2, because the results are so structured, they're easy to verify, which makes the whole network way more secure. 3, and this is the game changer, the mining process itself actually creates useful scientific tools, reusable quantum circuits. And finally, the code from the winners basically becomes the gold standard for everyone else.
And this is the real paradigm shift here. For years, we've heard about proof of work in crypto, right? You burn incredible amounts of energy solving these abstract math puzzles, and then the answer just gets thrown away. With this new Qubitcoin model, that's over. All that energy that's being used to secure the blockchain is now transformed into creating something valuable, something tangible, something that can be reused for actual scientific research.
This quote from the analysis just nails the big vision. Qubitcoin is trying to be more than a currency. It's trying to become a decentralized global network that is literally crowdsourcing the software tools that we are going to need to build the full-scale quantum computers of the future.
So when you boil it all down, what Qubitcoin is trying to do here is pretty profound. It's aligning the economic incentives of keeping a blockchain secure with the goals of making real, tangible progress in fundamental quantum science. Securing the network and pushing science forward become the exact same job. And that really just leaves us with one final, pretty provocative thought. We've been talking about one specific project, but zoom out for a second. What if this model could be used for other things? What if all the massive computing power we use just to secure our digital world could, at the same time, be used to help us solve some of the biggest scientific challenges we face? Now that is an idea we're thinking about.